Good morning, guys. Did you hear about this? David Blaine, a stuntman, just did this amazing stunt where he attached himself to a helium balloon, actually a bunch of helium balloons, and floated up into the air across the Great Basin Desert in Nevada. Now, that is something I think we've all wondered about. Anytime we've held onto a helium balloon and we're like, I wonder if it would pull me up into the air. I think that would be pretty cool. What would happen if a balloon or a set of balloons could lift us up into the air? Today I want to look at how does that work? How does a helium balloon rise? What makes it have that force? What makes it go up? Helium is a gas. Helium is this element here. It's number 2 on the periodic table. And it likes to hang out by itself. That's something that's really important to understanding how helium balloons work, because helium atoms, when they're packed inside a balloon, they don't attach to each other and they keep their distance from each other. They are all spread around. That's a lot different than the other atoms in our atmosphere. The other atoms in our atmosphere, like carbon and hydrogen and nitrogen, oxygen, they all like to attach to things. So when they are floating around, they are usually attached in pairs of 2s or 3s or even more. And even if they're spread out the same as a molecule, they are connected closer, so there are more of them in the same area. To understand density, we really have to do a counting game. If we have 2 equal spaces and one of them has 1, 2, 3, 4, 5 atoms in it, and the other space has 21, which one is more, 21 or 5? That's right. 21 is more, which means there are more particles packed into that same area, which means this is more dense, this is less dense. So if this is our helium balloon and it has a density of these 3 particles within the same space, and this is our atmosphere with denser air towards the bottom and less dense air toward the top, the balloon is going to rise until it finds that sweet spot where its density matches pretty closely with the density of the air around it. Now, the helium balloon could go up about 20 miles before it reached that sweet spot where it would just stay there until the tiny little particles of helium would leak out through the holes in the balloon. The helium is one of the smallest particles we know, and it would leak out until it spread out all across the Earth, and it would
go into the atmosphere
beyond Earth into space and just get whipped away by the solar wind. We literally are losing helium to outer space every single day because it's so light, it's so spread out, it gets up to the very top reaches of our atmosphere.
There is a helium shortage, so think about that next time you use helium balloons for your birthday party.
A hot air balloon is different than helium, but it works on the same principle. Instead of having a gas that naturally wants to be spread apart, you have heat. You add thermal energy to that gas, whatever gas is in the atmosphere, carbon dioxide, nitrogen, oxygen, and those particles will spread apart because of the heat, adding thermal energy and making them spread apart. And they spread apart, and then that hot air balloon rises until it finds a place that it belongs. And that's what we all want, right? We want to find a place that we belong. Whether it's a solid, a liquid, a gas, all of these matter, all of this particles of matter, they're looking for a place that they belong. They're looking for a place where their buoyancy, that's the ability of them to float, is. I'm going to give you some links today to learn a little bit more about how balloons work and how density and buoyancy work.